All right, we're going to do second part of 3.2. We're going to use a lot of the properties that we did on the previous video and previous day of taking notes, and now we're going to apply it. We're going to graph logarithms. You see, when you graph, they're really going to look like the exponential functions. Remember the exponential functions, you always got a horizontal asymptote. Well, if I switch the x and the y, all right, so as we switch the x and the y, instead of getting an HA, you can see right here, I have this outline, we're going to get a VA. But you're going to kind of have the same general shape, the boomerangs. The two things I have listed up top are two properties that we went over yesterday. We're going to use this a lot when we graph if I want to get 2 points. I know, like the log of 1, it doesn't even matter what the base is. I'll put the base as a. It's kind of pointless. But the log of 1 always equals 0. That gives us a good starting point. Now this, I kind of always call this the base point. If the base and the argument are the same, this always equals 1, because a to the first equals a. All right, let's do, I think I'm going to do 1, 3, 4, and 5, and then the other 4 we'll do in class tomorrow. There's a couple ones with natural log. Very first thing starting out, just like when I did the exponential functions, let's identify the asymptote first. Now think of it, I'm going to draw just a vertical line right here. We're going to get a VA. The only way that you would change the VA is if you move it left or right. So the VA is only affected if you have a horizontal shift. We have a horizontal shift for number 1 because the -2 is on the inside with the x. Here's the only thing that you do. Take whatever is inside the parentheses with the argument and set it equal to 0. So if you took x minus 2 and set it equal to 0, x equals 2 is the VA. You can never have an argument equal to 0. So I'm just going to graph this, x equals 2. Okay, and then I'm just going to make like a little xy chart for this. And this is where I'm going to use these properties here. Now, if I want this argument to equal 1, x would have to be 3. Because when I put it in here, right, when I put 3 in there, 3 minus 2 is 1. Log base 2 of 1 is 0. Now I'm going to use this one. I want to get that base to be the same. So if I want to get this base to be the same, I want this base to equal 2. Well, if I would have to do that, x would have to be 4. Right? If I put 4 in, and I get log base 2 of 4 minus 2, that's what that is log base, just writing it over here, log base 2 of 2, and I know that's 1. So I'm going to put 1 in. I'm going to put another 1 in, so that gives us what, like I know 2 squared is 4, I could put in 6. Right? If I put in 6 here, 6 minus 2 is 4, and you have log base 2 of 4, and I know that's 2. So let's plot those, and really you'll see, once you plot a couple points, you really know what the graph looks like. It's very easy. Okay, we got 3, 0, 3 zeros right here. We have 4, 1, and then we have 5, 6, then we have 6, 2. And then this goes up left to right, and then it curls down here, gets closer and closer to that VA, but it never hits. Okay, let's do number 3. Okay, number 3, we have 2 shifts. We have a horizontal and we have a vertical shift. Now, oh, you know what? I forgot to do domain. If you look at domain, you only have a graph here to the right of x equals 2. So domain is just x is greater than 2. Or if you put it in interval notation, it's 2 to infinity. So your VA is going to have a lot to do with the domain. Basically, the VA, it's either going to be greater than that number or less than it. All right, let's do number 3. Okay, as I said, number 3, we have both shifts. First thing we could figure out, the horizontal shift gives us the VA. So if you set that x minus 1 equal to 0, x equals 1 is going to be the VA. So let's do this, x equals 1. So there's the VA. Now let's make a little xy chart. All right, let's get values. I want this value here to be 1. So if I want that to be 1, x has to be 2. So when I put 2 minus 1 in there, this is what I have. If I write this out, I have log base 4 of 1, and then plus 3. I'm going to do this at the end. Now this quantity, log base 4 of 1, well, remember, always log of 1 is 0, but now we have a vertical shift, we have to add 3 to it. So I get 3. Okay, the other one is I want this to equal the base. So if I can take that x minus 1, the base is 4. Well, you know, x would just have to be 5. I'm going to put 5 in here. So if I put 5 into this, I get 5 minus 1 is 4. Then I get log base 4 of 4. And then you have to add 3. Log base 4 of 4 is 1. And then if you add 3 to it, you get 4. Okay, and I think if I wanted to try another one, well, let's see here. If the base is 4, I know 4 squared is 16. I could take this x minus 1, set it equal to 16. And if I did that, I would get 17. So then if I put 17 in this, 17 minus 1 is 16. So I have log base 4 of 16. Log base 4 is 16 is 2. And 2 plus 3 is 5. So you can kind of see how the y values keep going up by 1. Just like when I did exponential functions, the x values only went up by 1. So the x's increase exponentially here. So if I graph these, I'm going to graph 2, 3. 2, 3 is right up here. And then I have 5, 4. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 4 is right here. So this goes up left to right, and again it curls down by the VA. And then the domain is just everything's here on this side, so it's x is greater than 1. Or an interval notation of 1 to infinity. Okay, let's do number 4. You know what, let's do number 4, and then we'll call it quits. The rest we'll do in class tomorrow. Okay, the VA, if we look at this one right here, there is no horizontal shift. It's negative x. So if there's no horizontal shift, the VA is automatically x equals 0. So it's never going to hit the y-axis. That's x equals 0. Okay, now let's make our little xy chart. Okay, I want this argument to be 1. Now there's a negative in here. I can't plug in 1 because that gives me log base 2 of negative 1. You can never take the logarithm of a negative argument. So what that's telling me is the x values have to be negative. I'm going to put in negative 1. Because when I put in negative 1, the negatives cancel. And you get log base 2 of 1 and then plus 3. Okay, you evaluate the logarithm first. Log of 1 is 0. And then you take care of the vertical shift. So 0 plus 3 is 3. Okay, then I want this argument to be equal to the base. The base is 2. So then x would have to be negative 2. So if I made that negative 2, I would plug in negative 2 here. It would cancel out with the negative. So here you have log base 2 of 2, which is 1. And then you have 1 plus 3 is 4. And I'm just going to leave it at that. I know I could keep plugging in more values. But you see, if you just set the argument equal to 1 and set the argument equal to the base, you'll get 2 points. And that's kind of all that you need. So I'm going to graph this. I have negative 1, 3, which is right up here. And I have negative 2, 4. And there's negative 2, 4. So now you can see this graph basically flips over the y-axis. This goes up here, and then it curls down by the VA. So now when I do the domain, now I'm over here in the negatives. This is the domain. It's going to be x is less than 0. Or if I put it in interval notation, negative infinity to 0. And I always use parentheses because it doesn't hit that VA. All right, so you can always see, just like the exponential functions, get the VA first. Then you can use a little XY chart, plug some points in. You're going to see your Y values always go up by 1. Because when we did the exponentials, the X values always went up by 1. Now we just switch the X and the Y.